In this problem, we want to understand the latent heat and phase changes, how we can calculate the energy required to pass from one state to another state with phase change or no phase change. First of all, we have a cube of ice with a mass of 1 milligram. Initially, we have a solid state object at a temperature equals to minus 30 degree. We pass to the final state with a temperature 120 degree, and we have a vapor state. So we cannot solve this problem directly from this stage to this stage, because between them we have many steps or many stages to study. First of all, I give you a useful data, the specific heat of ice, of water, of steam, and the latent heat of fusion and vaporization. You know, if you pass from liquid to solid or from solid to liquid, we use L fusion. If you pass from liquid to steam, we can say vapor, or from vapor to liquid, we use L vap. I will explain. First of all, we have here a cube at the initial state, state 1, the temperature T1 equals to minus 30. So I want to pass to the final state, T final, with, let's say, here we have a steam vapor. The temperature equals to 120 degree. As I said before, we cannot pass directly from this one to this one because we have many cases to study. First of all, I want to add Q to the system to pass from state 1 to state 2, where the cube is always in a solid state. Here we have solid state, and here we have a solid state. We can say we keep the same phase. We have no phase change. The temperature passes from T1 to T2 equals to 0 degree. To this point, we don't have water. We have only a solid cube of ice. Okay, now if we can add to the system a quantity of heat to pass from state 2 to state 3, where the cube will be converted to water, liquid state. We have liquid. So this is the third state. The temperature is constant. You know, this is a property of the water. If we have phase change, the temperature doesn't change. It's constant. Okay, now I add Q to pass from 3 to 4, where the temperature increases from T3 to T4 equals to 100 degree. And we keep the same phase, liquid. And we have fourth state. Now, finally, we have to add Q heat to pass from the third excuse me, from the state 4 to 5, where the water is converted to steam. You know, in the case where we have a phase change, the temperature doesn't change. In this case, we pass from solid to liquid, and here we pass from liquid to vapor to steam. So the temperature is constant in these two cases. Okay, here we have state 4 and state 5, vapor. The final point, we pass from vapor phase to the vapor phase. The final one is 6 by adding Q5 to 6. As you see, the temperature increases from 100 to 120 degrees. This is a general view of the problem. And to study these cases, we have to take 2 by 2. The first one, we take these two cases to pass from solid to solid. You know, if we have same phases, we have the same phase, we use Q equals to mc delta T. If we have a different phases, we use Q equals to ml. We have LF or LV, okay? From solid to liquid, we use LF, and from liquid to vapor, we use LV. Now we pass from solid to solid, so Q equals to mc delta T. Delta T equals to T final T2 minus T1. You know, the mass doesn't change, equals to 1 milligram. We have to convert the mass to kilogram, so equals to 1 times 10 power minus 3 kilogram. C, we have here ice to ice. So C ice, we look here, C ice equals to 2090 joule kilogram per kilogram C. So times 290, T2 equals to 0 minus T1 equals to minus 30. So we have minus 30. We do the calculation, we get 62.7 joule. This is the energy required to pass from the state 1 to the state 2. We keep the same phase. Okay, let's illustrate this value on this axis. Here in the vertical axis, we have the temperature, and here we have the energy added to the system in joule. Okay, let's say here we have the initial temperature equals to minus 30, and we pass to 0. And the energy required equals to 62.7 joule. Okay, here we have like this, we pass from the initial state to the final state. Let's say this is stage 1, stage A. We pass from state 1 to state 2. Second, now we take we pass from state 2 to state 3, from solid to liquid. As we have phase change, the energy required equals to ml. As we have a change, we pass from solid to liquid, we use L, latent heat of fusion, to pass from state 2 to state 3. M doesn't change, equals to 10 power minus 3 times LF, latent heat of fusion, which is equal to 3.33 times 10 power 5. Okay, we calculate, we have 333 joule. This is the energy required to pass from the state 2 to the state 3. As you see, the temperature doesn't change, so we pass from state 2 to state 3 with the same temperature. T is constant, equals to 0. And the energy added equals to 333 joule. The next one, we pass from liquid to liquid. As we have the same phase, liquid, so we use Q equals to mc delta T, T final, T4 minus T3. To pass from 3 to 4, as we have liquid, water, so here we have C, water. M equals to 10 minus 3, C water equals to equal 4,186 times T4 equals 100 minus T3 equal to 0. We calculate, so equals to 4,018.6 joule. This is the energy required to pass from state 3 to state 4. As you see, the temperature increases from 0 to 100. And we notice this stage by, let's say here we have B, to pass from 2 to 3 and to pass from 3 to 4. Let's say we have a phase or stage C. And the energy added equals to 418.6. We pass to the next one. From liquid to vapor, the temperature doesn't change, as I said before, because we have a phase change. So in this case, Q equals to M times L, 4 to 5. As we pass from liquid to vapor, we use L vap equals to 10 minus 3 times L vap, a given value equals to 0.26 times 10 6. So we calculate the value equals 2260 and 23 joule. The required energy to pass from state 5 to state 4 to state 5. We illustrate this one. The temperature doesn't change, equals to 100. And let's say here we have B, here C, and here D. Stage D, and the energy added. Okay, let's say like that. Equals to 2260 joule. The final one, we pass from 5 to 6. The temperature increases from 100 to 120. As we have same phase, so Q equals to MC delta T. Delta T, T final, let's say T6 minus T initial, T5. We have steam, it's a given value. Steam equals to, okay, the mass 110 power minus 3. C of steam equals to 2010. The temperature final equals to 120 minus 100. We calculate, we get 40.2 joule to pass from 5 to 6. And the temperature increases from 100 to 120. This is the stage E. And the energy required equals to 40.2 joule. So here, to calculate the total energy required to pass from state 1 to state 6, we have to add QA plus QB plus QC plus QD plus QE. So Q total to pass from 1 to 6 equals to QA plus QB QC QD QE equals to 62.7 equals to 3114, I think, 0.5 joule. This is the total energy required to pass from state 1 to state 6. Now, just if you want to pass from state 6 to state 1, from vapor state to solid state, we get the same quantity but in the negative value sign, because you have to liberate, you have to release a quantity of heat. When you release this energy, Q must be negative. So to pass from 6 to 1 equals to minus 3114 joule.